In this video of simple harmonic motion, we will derive an expression for the velocity of the oscillator. To find the velocity, we can start with the expression for the displacement x equals to a sin omega t plus phi. If phi is 0, that means the motion is starting from the mean position, then x is a sin omega t. The relation between velocity and displacement is given by this expression. Velocity is rate of change of displacement. So differentiating x, we get d a sin omega t by dt. Since a is a constant, we take it out. Now a as it is, differentiation of sin omega t will be cos omega t, and applying the chain rule, we have to apply the differentiation to the variable inside the bracket omega t. So dt by dt will be 1, and that omega will be multiplied in the front. So v equals to a omega cos omega t, or v equals to omega a cos omega t. And that will be your expression for velocity in simple harmonic motion when the motion starts from mean position. This equation can be simplified as omega a, and instead of cos omega t, we can write square root of 1 minus sin square omega t. If you remember, cos square theta plus sin square theta is 1, so we can rearrange it in this form. Multiplying the a inside the square root, we get a square, and here a square sin square omega t. Now a square sin square is nothing but x square, so omega square root of a square minus x square is another expression for v. When x is 0, v will be v maximum, because here we have the subtraction of the displacement. So if you put here x is 0, then square root of a square will be omega and a as it is. So v max will be omega a. At x equals to a, we will have the minimum velocity. So if you put here a square, then a square minus a square will be 0. So v minimum is 0. To represent this in the form of a graph, so x is a sin omega t. We will have a sine curve with the values ranging from minus a to plus a, and for v equals to omega a cos omega t, we will have cosine curve with the value ranging from minus omega a to plus omega a. Now if the motion was starting from the extreme position, then phi will be pi by 2, so x will be a cos omega t. Following the same mathematical steps, differentiating with respect to time. Again, a is constant, it comes out, so d cos omega t by dt. Here, differentiation of cos is minus sine a as it is, and again the chain rule applied to omega t will give you omega in the front, so v will be minus omega a sine omega t. Representing this graphically, we get for x equals to a cos omega t, we get a cosine curve with the value ranging between minus a to plus a, and v equals to minus omega a sine omega t will be a sine curve which goes to the negative maximum first and then to the positive, value ranging between omega a and minus omega a. If we visualize this, then at x equals to 0, v will be v max, so v max is omega a. At the extreme position x equals to a, v will be v minimum, that is v will be 0. So the object starts at maximum speed from the mean position, slows down as it goes towards the extreme position, stops and then turns back. As it passes from the mean position, again it has maximum velocity, and then again it starts to slow down and stops at the other extreme position. For more numericals, follow me on Instagram. My account is Solutions by Tall Teacher. Don't forget to like, comment, share and subscribe to my channel. Stay tuned for updates.